In this video we're going to look at the concepts of marginal revenue and average revenue and to see how they are related. To do this we're going to take a slightly quantitative approach. So if you're not happy with diagrammatic proofs or little bits of mathematics or whatever, don't worry too much about it. Understand the relationships. This is what underpins the relationships, and for those of you who've got those techniques, you'll benefit from looking at this particular session. So let's start. As sales increase, the price may have to be reduced in order to stimulate further market growth. That's pretty straightforward. As sales increase, sometimes we've got to cut the price, or producers have got to cut the price to induce even further sales. This means that the relationship between the revenue flowing into an organization and output will not be a straight line. It's not proportional. If you reduce the price, it doesn't mean that output will increase by the same proportion. So we're probably dealing with non-linear relationships, and that's likely to be the typical relationship. If I can put the cursor onto the screen for a second. As output increases, we have to cut price at some stage to stimulate further output, further demand. And as we cut the price, the line becomes curved. So that will be our total revenue curve. Eventually, if we carried on cutting the price, the curve would start to come down. Revenue would start to fall in the company. That means you've overcut the price. And if you continue cutting it right to zero, then of course revenue would be equal to zero, but output would be somewhere up here. That would never happen in a commercial organization, I presume. So the point is that to stimulate further output, price has to be reduced. It gives us a non-linear relationship. Now let's start by looking at the average revenue and see what happens here. And I'm going to use some diagrams to illustrate what happens to average revenue. First of all, let's start with what we know already, which is our total revenue curve. We've just drawn that, and we have this non-linear relationship. Now let's take any output level, let's say Q1, and the associated revenue, total revenue, will be R1. So the revenue is R1, the output is Q1, the sales are Q1. Now if we take a different level of output, say Q2, the revenue associated with that will be R2. So you can see that as output is increased, the revenue is increased, but by not as much. It's proportionately less. Now let's just bear that in mind for a second. So we've got two outputs, Q1, Q2, got two revenues, R1 and R2, and you can see that R2 has increased, but not by a lot. That's because the curve is starting to bend downwards. Let's do it again. There's the R1 and R2 as we had before. Now let's draw a second diagram underneath this to show what happens to the average. This diagram underneath, it's got currency on the pounds on the vertical axis and output on the horizontal axis, and I've marked a point on here which represents the ratio R1 is to Q1. So it's R1 divided by Q1. Let's put the cursor back on. Here we go. If you look at this ratio here, R1 is to Q1, which is just our average revenue, is the total revenue, R1, divided by the output, Q1. That's how you work out an average. Not very difficult. Now, in fact what we've got here is R1, this distance up here, which is the same as the distance here. So it's the same, that's R1, the length of that line is R1. Q1 is that line there. So really what we're doing is we're dividing this line, the vertical line, by the horizontal line. And if you do that, you just get, well, you actually, in mathematics, you get the tangent of that angle. So, but it's a representation of the angle here. It tells us the angle. Let's take a different point. Let's take the second point we had before. This is on Q2, and the revenue was R2. Now, the ratio R2 is to Q2 is less. Well, you can see the angle is less. This angle here, the first one, is greater than the second one. So, that ratio there, R1 is to Q1, is just the average revenue at Q1. This one here is the average revenue at Q2. You can see it's less. It's less because the angle is less. We can join up those points. When you join them up, you get a line representing the average revenue. So the average revenue is downward sloping. Okay, that's what it looks like. It's just the average revenue. The average revenue curve is the demand curve. If we just put average revenue in here, an average revenue is equal to total revenue. Total revenue is price times quantity. That's how you work out the total revenue, the price times the number of units sold. The average revenue is price times quantity divided by the quantity. The Q's cancel, leaving the price. That's a demand curve, or it's a representation of a demand curve. Marginal revenue is measured by the change in total revenue associated with the change in output. This one's a bit more complex, so let's start by having a look at marginal revenue. We've covered average, now let's look at the marginal. So it's measured by a change in total revenue associated with a change in output. So if we do that in this expression here, we say the marginal revenue, here's the marginal revenue, MR, is equal to delta. Delta is the Greek letter for D. But it's the Greek letter which we use to represent change, the change in. So it's the change in total revenue divided by the change in Q. The triangle here, delta, it means change in, the change in Q. So marginal revenue is equal to the change in total revenue divided by the change in quantity. Let's draw that on a diagram. Here's our total revenue curve we had before. Now, if we take a point A and we change the quantity, if we change the quantity, then the total revenue will change. We change over here to delta Q. So we move on from A, we add delta Q. That means we get this extra total revenue. Now the marginal revenue is this one, the change in total revenue divided by the change in quantity. Let's have a look at that. Let's just expand it and have a look at it again. Okay, we've got A, B, C. And you can see that the true curve, the true revenue curve, is this curved line AC. It's this one here. It's the curved one. I've exaggerated it because I've exploded the diagram to have a look in more detail at what's happening here. So AC is a curve. Well, okay, AC is a curve. However, the ratio delta total revenue, delta TR, divided by delta Q will give us the gradient of this straight line from A to C. So delta TR divided by delta Q will be, that's the slope of that line there. You can see the original one was wrong. It was wrong because it was away from the true curve. The true curve was the curvilinear. this one here. If I take a second point, E, you can see that the marginal revenue has changed, because now we're taking a smaller change in quantity. We're not taking this big change in quantity up here. We're taking about half of that. But again, total revenue has changed, and again you can see here that the gradient of the line AE is bigger than AC. We can expand this one now, because this one's also wrong. It's wrong because we've got this error here. We've got this error that we're not counting for. So we could divide it off again and say AF, where F is somewhere in here. We're getting smaller and smaller and smaller. And AG now, this new one, not AE anymore, AG, because we're now gone into the middle of this one. AG has a new marginal revenue, a higher marginal revenue, but again there's an error. You can see the gap between the true curve and the one I've drawn in. The gap is not as big as it was before. We started off with a horrendous gap, then it got smaller because we halved the distance. Now we're halving it again, and you can see the gap is getting smaller. But we can carry on doing this. We can do this on and on and on. We'll always have a gap. So what we do in the end is we say, well, we're going to take a very, very small change in output and see what the associated very, very small change in total revenue is. And the marginal revenue, if we can just put the cursor back here, the marginal revenue then will be D, not delta anymore, not the triangle, D now. D represents an infinitesimally small change in. It's the calculus. For those of you who have done mathematics, this should be obvious to you. But D is a very small change in the total revenue divided by a very small change in the quantity. So small we can't really draw it on a diagram. But yet it's real. There is a difference. It's just so small we can't represent it. And that's the essence of the calculus. So marginal revenue is the change in total revenue divided by the change in quantity. So it's DTR by DQ, as we say in mathematics. DTR by DQ. If we take the change in quantity to be very, very, very small here, we're really talking about a tangent at the point. The marginal revenue is the slope of the total revenue curve for a given level of output. So if I just draw a tangent in here, that's what we're talking about. We're talking about the slope of the tangent at that point is the marginal revenue. If I draw it at a different point, you'll see that the marginal revenue is less. This relationship is less. It's less again. So it seems to be declining throughout. Here, interesting one, it's fallen again. The gradient has fallen. In fact, the gradient here is 0. It's a horizontal line. And of course, in mathematics, when using the calculus, when we differentiate an expression and set it equal to 0, we find the maximum. And that's what we found here again. We found that the maximum total revenue, here's the maximum total revenue here, it dips down afterwards. The maximum is when the tangent is horizontal, it's just touching there. So at that point, revenue would be maximized and the marginal revenue will equal 0. So when the marginal revenue is equal to 0, total revenue is maximized. That's a good conclusion. When marginal revenue is equal to 0, total revenue is maximized. If we go a bit too far, you can see here that the marginal revenue is negative. It's starting to fall. Okay, so not good. Marginal revenue is falling. Total revenue is falling. Marginal revenue is increasing. Total revenue is increasing. Marginal revenue is increasing. Not at the same rate, but still causing total revenue to increase. Marginal revenue is equal to 0. It's horizontal. There is no gradient on the tangent. So the total revenue is maximized. So the slope is equal to 0 at that point, and at that point, therefore, MR is equal to dTR by dQ, the change in total revenue divided by the change in quantity, where D is a very, very small measure. And when that's equal to 0, then the total revenue is maximized. So when marginal revenue is equal to 0, then total revenue is at a maximum. That's worth remembering. Okay, let's play a few games with quite simple mathematics, but nonetheless some mathematics, just to see what's meant by it all. Let's start with this one for a start. We know that the marginal revenue now is the change in total revenue divided by the change in quantity. We know that total revenue is equal to price times quantity. The total revenue coming into a business is equal to the number of units we sell times the price. The marginal revenue is the change in the total revenue divided by the change in the quantity. So that's what we've just had in the last couple of slides. Over here I've just expanded the total revenue to PQ, so not very difficult. Now let's just start manipulating this to see where we can get to. Well, for a start, we've got this relationship here, and if you've got that relationship, that's called a product. And if you differentiate a product, you have to use a product rule in the calculus, and that's the product rule. Okay, so we just take Q dP by dQ plus P dQ by dQ. Right. Yeah, if you've studied the calculus before, you'll realize that is the product rule, and everybody who does calculus knows and loves it. Well, may not. However, you can see we can get rid of this one here. I mean, that doesn't mean anything, so just drop that. So now we can rewrite this as this plus P. That's just 1, so just get rid of it. P. So marginal revenue is equal to that. Okay. Now comes a clever bit. If we take P outside of this bracket, so we're going to multiply everything inside by P. If we do that, we have to divide by P. If you divide inside by P and multiply by P on the outside, it won't make any difference. So we take P out and we divide by P. In other words, the P's would cancel, just leaving us this. But if we take P out, we divide by P. And of course, over here we'd have to divide by P as well. So P over P. All we've done is we've taken P outside of the bracket. So we have to divide what's inside the bracket by P, so it's to leave everything unchanged. Now this one here is interesting because that is the elasticity formula upside down. That's the elasticity formula upside down. So marginal revenue is equal to P into 1 over the elasticity plus 1. The P of this one here is 1. So that's 1. And this one here, this formula, if you look back on your elasticity formulas, you'll find that that is the elasticity formula, except it's upside down. So there's the reciprocal. So eta, this one here, eta, is just equal to this expression here. It's the elasticity. Well, it's this one upside down. It's the elasticity expression. So eta is the elasticity of demand. So now marginal revenue is equal to the price into 1 over the elasticity plus 1. Okay, we're getting towards a useful little expression here. We haven't got there just yet. Let's just carry on. So we've got that. Eta, the elasticity figure is always negative. Well, for downward sloping demand curves, it's always negative. And by convention, of course, when we do calculations, we just simply ignore the minus sign. Well, if it's always negative, if eta is negative, then in fact we should move that over there. We should say marginal revenue is equal to price into 1 minus 1 over eta, because this one's a negative, so move it over there, move it to the right. Okay, that's the relationship between marginal revenue and price. Price is average revenue. That's the relationship there. If we multiply price by this figure, we'll get the marginal revenue. When marginal revenue is equal to 0, total revenue is maximized. We just proved that earlier with the diagram when we had the tangent, the marginal revenue as a tangent, and we had it horizontal, just touching the total revenue curve. So we've got that. We've also got this. We've just established that the marginal revenue is equal to the price into 1 minus 1 over the elasticity. Now let's see what the value of elasticity will be when total revenue is maximized. So if we set this equal to 0, because we know marginal revenue is equal to 0 when total revenue is maximized, if we set this expression equal to 0, we should be able to work out the elasticity figure. That's the only one we don't know. So let's just take, we've got this one, this is over here, take that. Now multiply it by p, multiply the p's inwards, so we got p minus p over eta, p minus p over eta is equal to 0. Simple multiplication. And if we now take this over to the right hand side, we simply have p is equal to p over eta. So that's straightforward. Therefore, eta must equal 1 when revenue is maximized. So when elasticity is equal to 1, total revenue is at a maximum. That's an interesting conclusion. So when we look at an elasticity figure, if it's 1, we know that total revenue is maximized. So we've got a benchmark. Right, let's leave that. That's what I wanted to show in there. I wanted to show this relationship up here, or this one, and I wanted to just talk about that. And this will come back to us later. We even look at market structure and we look at different aspects of the subject. Let's have a look at the relationship between marginal and average revenue. And let's start with, let's be grandiose and call it a theorem. So when the average revenue curve is a straight line, this only works for straight lines, then the marginal revenue curve will have twice its gradient and the same intercept. Okay, so when the average revenue curve is a straight line, has to be a straight line, then the marginal revenue curve will have twice its slope, but will start at the same point. Let's prove that. So we'll let the price equal A minus BQ. A is the intercept term and B is the gradient of the line. Now if we multiply by Q, we'd have total revenue is equal to price times quantity. Yes, total revenue, price times quantity. We know what price is. Price is equal to A minus BQ. That's a straight line. In mathematics, if you draw that, it's a straight line. There are no exponents, there are no squares or cubes or complicated expressions in there. It's a straightforward, well, it's a straight line. And now, if we multiply this by Q, in other words, if you multiply P by Q, multiply multiply P by Q, we get AQ minus BQ squared. Minus BQ squared. Marginal revenue is equal to the first differential of the total revenue with respect to the quantity. So, if we differentiate total revenue, TR, with respect to Q, you have to have a little bit of calculus here. If you do that, you'll find this expression here. The 2 here, the exponent here comes down, we reduce it by 1, so we get A minus 2BQ. So marginal revenue is equal to A minus 2BQ. Okay. What have we got then? Well, we've got our average revenue curve is downward sloping. It's a straight line, so that's okay. This up here would be the intercept term, that is A, and the gradient is minus B. So the slope here is minus B, and that's the intercept term A. Then we've got the slope of the second one, the marginal revenue curve, this one here. Here's the marginal revenue. The slope of the marginal revenue curve is minus 2B. The slope of the average revenue is minus B. So this one's minus B, this one's minus 2B. So whenever the average revenue is a straight line, the marginal revenue will start at the same point, it'll start at the same intercept term, the same value up here, A, but it'll have twice the slope, twice the gradient. And that's, again, just a useful little bit of information which will help us when we're looking at even market structures later on. So that's a useful piece of thinking. I realize a lot of these slides are based on mathematical techniques that we're not covering, for example the calculus or bits of mathematics. You may not be comfortable with that. All I'm asking you to do really is to remember the relationships that I've indicated. How we got there, you won't be asked for any of that, but how you got there is it's up to you. Some people are curious, they want to find out. They don't want to be just told that's the relationship. They want to find out why is it the relationship. So what I've done is I've given you the proofs as to why that is the case it is. So have a look over those, and if you're that way inclined, if you're not that way inclined, if you don't like mathematics and this type of thinking, just remember the relationships if you're happy with that. So I suppose really in this case it's whatever floats your boat. Okay, that's it I think.